Welcome to the lesson BIPV Technologies. Today I will give you an insight into our main BIPV concept and a hint of products existing today on the BIPV market. As you can see, looking at common urban contexts, buildings offer large surfaces for photovoltaic integration, and these mean big opportunities for the local energy production. How we can integrate PV into the buildings? We can use both the roof and the facade, with PV accessible or not accessible from within the building. We can use also other parts of the building, external to the envelope. Some examples are balconies, shading devices like overhangs, and so on. That said, there is an important issue that we have to face with. The number of existing building typologies is infinite. BIPV has to be able to fit from several points of view, with many different buildings, moreover placed in contexts that are different for appearance, meteorological conditions, cultural identities, and so on. BIPV has to be good looking. It has to be in harmony with the overall building image and respect the surrounding environment. Otherwise, what happens? It is not accepted by the people. It means no PV. One important point, so, is the aesthetic integration. Another important aspect is the constructive and functional quality. BIPV usually substitutes a traditional building component, so it has to efficiently provide all the functions of that component. For instance, if we have a semi-transparent PV roof, it will provide shading to the space below. If we have a ventilated facade with PV cladding, it will provide thermal control for the building. BIPV has to be safe and guarantee integrity, and this is what we call technology integration. Which other aspect BIPV should meet to have a good performance? BIPV should produce electricity when and in the quantity that the building requires. In a house, we might probably need electricity in the morning and in the evening. On the contrary, in an office, during the central hours of the day. Again, potential control strategies can modify the demand profiles. Moreover, there can be different irradiation conditions. What we call energy integration is so important to have a good interaction of BIPV with the building energy system, maximizing the local use of the produced electricity. In the last decade, the development of BIPV products has come a long way in order to meet the most varied needs of the building. Let's start with a big picture of some products that we will see today. You can see modules, mounting systems, and energy systems. Let's see more in detail some of the products that you can find into the current BIPV market. Please do not take it as an exhaustive overview, but just as an insight. I will start from the modules. First, you might probably know that we can distinguish two main categories: modules based on crystalline silicon technology and modules based on thin film technology. And you can find, both for these two categories, flat and rigid modules or flexible lightweight modules. Looking at these images, what do you see? One aspect that immediately arises is the multiple color of the modules. The modules are not just blue anymore. They are red, black, brown, green, white, transparent. We can modify the color by printing or adding additional layers. We can act on the front material, for example, coloring the glass itself. We can use colored active PV material, for example, colored cells or backsheet. You can see that a wide number of colors can be achieved. Another aspect that we note looking at current market is the wide variability of transparency level of the module. This can be done in several ways: by distancing or holding the active PV cells, cutting strips of cells, laser scribing thin film material, using thin absorber layers that do not fully absorb all the light. There are also luminescent solar concentrators that guarantee full transparency. Color and transparency have not been the only fields of development. The modules can be customized in an infinite number of shapes. You see there some examples. In general, the manufacturers are working to improve the module's performance also regarding to other aspects, other than the electricity production, of course. For instance, the thermal and noise insulation, the mechanical resistance, the durability, the safety. The mounting systems for BIPV, as for the traditional building components, are several. They can be made of steel, aluminum, wood, metal sheets, or other materials. They can be standard or customized. And the same is for the fixing systems. We can use simple brackets, wall plugs, clamps, and others. Or, for instance, for flexible modules, we can use adhesive, special glue, and others. It depends on the modules and the building features. What is so important when dealing with BIPV is to consider some aspects. Of course, BIPV has to be functional, safety, and good-looking, as it was a traditional building component, but let's consider also that it needs a proper ventilation, otherwise a bad performance and critical problems can occur. It should be easily mounted and dismounted. It generates electricity, so be careful to fire risk. For energy systems, we mean the devices that are used to manage the produced electricity within the building. For instance, they can transform DC in AC, control and optimize the electricity flow, store it, use it for the building heating and cooling. In this slide, you can see an inverter with integrated battery, a microinverter, a special junction box, a power optimizer. They can be helpful in handling several issues of BIPV, like the aesthetics. A microinverter like this can be easily hidden. They also can handle the common problem of the module partial shading, or of the multiple orientation of modules in a BIPV system, problems that could lead to highly decrease the overall system performance. As for the modules, also for these devices we have to be careful to guarantee a proper ventilation to avoid overheating and other problems. Yes, because beside the quality of the technologies, don't forget the importance of the design part. To use the most innovative technologies available on market can be nothing if you do not go through a proper design process, considering all aspects related to BIPV.